All right, we're going to go ahead and get started. So thank you everyone for joining us here for our webinar, Autodesk TruNest for Advanced Digital Manufacturing. My name is Tom Neville, and I am the manufacturing team lead here at Synergis Technologies. And I'm very excited to be presenting today with our partner, Majestic Technologies. I'll transition to Trevor at Majestic to go over a little bit more detail about today's presentation and an introduction to their company. But I wanted to take this opportunity to give a brief overview on who Synergis is for those of you who don't already know. We are a 30-plus year Autodesk reseller, consultant, service provider, and training location. We serve customers in the AEC space, in the government space, in the education space, and obviously for today's presentation, the manufacturing space. Our primary focus is helping customers of all sizes become more competitive, innovative, and successful through leveraging their investment in the Autodesk solution set. As manufacturing has changed over the past 10, 20, 30 years, it's no longer enough to just have a CAD tool or to just have an ERP tool or just a CRM or DM. You see the point. Products are mature, margins are thin. Most of you manufacture a very mature product that has gone through rounds and rounds and rounds of iterations. Manufacturers are already excellent at product innovation. What we want to do as a partner is help you extend that excellence through to process innovation. To that end, we look to establish strategic partnerships with companies that have technical expertise in areas that we feel would be incredibly beneficial to our customer base, and one of those is Majestic Technologies. So thank you. Trevor, over to you.
My name is Trevor Cohn, and I'm an account manager with Majestic Technologies. And today I'm going to be talking about TruNest for advanced digital manufacturing. Now, before I get started, I want to just offer a really brief history of TruNest and the Majestic company. The current company, Majestic Technologies, was actually formed by the founders of Majestic Systems. Majestic Systems is the company that developed the original TruNest solution back in the early 90s. So our CEO, Greg McLean, and our CTO, Mike Spellman, actually formed Majestic Systems back in the early 90s, developed TruNest, and then ran that company up until it was acquired by Autodesk back in 2014. So now Majestic Technologies was started as a strategic partnership with Autodesk, and we work alongside Autodesk to support and provide services to all the TruNest customer base. Now, with approximately 30 years of development, TruNest has really evolved to benefit best practices for many different industries. This includes transportation, aerospace, construction, power generation, and many others. You see some of these are represented here. Now, some of our larger clients are actually household names, and many of these customers have been using TruNest successfully for over 20 years. Now, you can see that many of the major aerospace companies are current customers represented here. But just want to point out that our software can be used by really any type of manufacturing organization that's cutting parts from a flat stock type of material. Now, TruNest can really bring a great deal of value into a manufacturing organization in many different ways, but I've broken this down into 4 specific areas of automation here where I feel that TruNest can provide the greatest impact. First thing I want to talk about is material optimization. Now, with TruNest, we can reduce scrap by utilizing our 60-plus algorithms to calculate the best use of material. The algorithms take into account specific information such as the cutting application and available materials. Second is machine tool flexibility. TruNest is a universal application that can support many different machine tools and cutting applications. It's one solution for all of your machines. Third, data compatibility with your existing Autodesk design tools, Vault PLM, and most other third-party CAD platforms. And finally, seamless integration to most ERP or MRP business systems for a complete digital workflow. Now, we nest and cut for any type of flat stock material, and they all, kind of offer their own unique cutting requirements. For example, a honeycomb sandwich panel will often require NC programs to support 2-sided processing for the X, Y, and Z axes, cutting metal grading material where the parts need to be nested, where the grid pattern of the grading to align properly. That requires a very specialized cutting technique, which is much different than cutting solid sheets of metal. So TruNest can manage the cutting for all of these different type of scenarios. And one of the primary benefits of TruNest is the ability to program for any machine type with really any major brand of CNC controller. Some of the most common machining tools that we currently support are going to be lasers, punch presses, plasma cutters, and water jets. However, we can generate NC code to program just about any machine that may be required by our customers. And when a customer implements the TruNest system, there are many efficiencies that are introduced into their manufacturing processes. The native CAD data is utilized for automatic nesting, and the optimum material size is also calculated. Material consumption is also optimized, and the performance and throughput of the machine tools are improved. We also offer the ability to reduce production lead times and to maximize schedules by nesting with the improved efficiency. TruNest offers the ideal material for the project, nests multiple jobs together, and prioritizes orders to drive down costs and also ensure that delivery targets are achieved. Now, with a traditional type of CAD to TruNest system that does not include an ERP integration, native CAD data is consumed by TruNest for automatic nesting. Then the NC files are created, sent out to the shop floor to program the various type of cutting machines. Now, with an integrated system, TruNest can consume sales order data from ERP, MRP, schedule the nesting projects, and then select the correct inventory. Then the NC codes are provided to the shop floor and reports are generated. This allows us to offer support to smaller shops that may only run, one or two different cutting machines, or support larger customers that have multiple facilities and many different machine tools for their very sophisticated workflows. So Majestic Technologies and TruNest can bring a great deal of value to any of nesting operations, regardless of the size. Now, these workflows are actually supported because TruNest is built on an enterprise relational database platform, which allows the solution to work with third-party applications in real time. ODBC, or Open Database Connectivity, allows the ability to integrate to a wide variety of database platforms. Now, this is accomplished with a direct connection that does not require conversion to ASCII files. Now, with this database connection, we can take large amounts of data seamlessly and digitally from an ERP system to propagate the databases that are located within TruNest. So information such as order quantities, bill of material, part assembly, part details, part subassemblies, due dates, and different details like that can all be fed from the ERP system into TruNest. Then these nesting project details will already be determined, and then the operator can have the option to make any necessary modifications afterwards. Now, within the TruNest database, our users can define parameters for their more common or standard types of nesting projects. Now, this typically accounts for about 80 to 90% of the projects with our existing customers. So for each type of material or each type of part, the operator can designate the material to be cut on one specific machine. So the curve, the separation, and grain constraints can all be applied within the database to create standard nesting environments. Now, this really just removes the amount of user interaction that's required, and that reduces human error and then greatly reduces the hours that the engineers spend on the nesting setup. Now, the information that is provided from ERP is seamlessly leveraged to propagate the TruNest database. Again, this is in real time. So details such as order status, customer information, part numbers, and material details are then used in downstream nesting and manufacturing processes. Then after the information is consumed for nesting, TruNest can then provide additional details such as the material usage, the machine runtime, order statuses, send all that back to the ERP system for a complete closed-loop digital workflow. So the main point that I really want to try to drive home with this slide is the fact that all nesting systems are not the same, and that each nesting system will take a different approach to the manufacturing process. Again, TruNest does offer over 60 different sophisticated algorithms and gives us the ability to create the most efficient nest result for each unique project requirement. And that's regardless of the volume or the complexity of the job. And the example shown here, a nest offering only one result can produce an effective nest. However, by using the numerous algorithms within TruNest, the nest example to the right demonstrates the improved efficiency offered by the TruNest engine. Now, with this specific project, TruNest was able to continue to solve after running one algorithm. Now, this resulted in a slightly different rotation of the parts and a higher yield with additional parts from the same size material. So this saves time and it reduces the scrap rate of some very expensive materials. TruNest is what we call a CAD agnostic system. I'm sure most of you are familiar with that term. Really just means that we have the ability to work with any type of CAD system. So for the Inventor or Vault users, the native CAD data can be accessed by TruNest to eliminate any need for DXF or IGES translations. This maintains a single source of truth. So TruNest comes standard with any CAD functionality that gives the ability to read design data from other CAD platforms if required. So your CATIA, SolidWorks, Solid Edge, PTC, all those type of CAD files are supported. And we can also import and leverage other industry use formats such as DXF, ASCII, UG files, all ISO, and many more are supported. Even your legacy NC files from a wide variety of cutting machines can be used as input into TruNest and then translated back into the preferred CAD application if needed. So this gives our users the ability to maintain their existing software, the ability to nest and program all of their machines within TruNest, and that eliminates that burden of trying to program each separate machine with the software that comes provided by the machine manufacturer. So for Inventor, we offer a native seamless interface into TruNest. So this gives us the ability to map part-specific metadata directly from the CAD files and right into TruNest. So your grain direction information, your part details and quantities and material information, that can all be carried through and then leveraged within the nesting system to provide some greater process control. So in 1991, TruNest was one of the first nesting programs to automatically nest the actual shape of the part, including your arcs, lines, and splines. So prior to TruNest, the nesting systems were using outlined representations of the part. A lot of this was due to the limited computing power at the time, but large rectangles were typically nested in place of the actual part shape. So this was actually corrected by the TruNest team, and this was done to save money that was wasted on an excessive amount of material scrap. So this image here really just represents the fact that TruNest does not simply nest the largest part first, just to nest smaller parts around it. So to maximize material utilization, we're able to move the boundary of the material during the nesting process. So oftentimes with competitive nesting systems results, you'll notice that the largest part is always located on the bottom left side of the material. So that reduces the potential options for improved material usage in that nest project. Now, if you really ever want the ability to test out a nesting program or a nesting system, I would recommend using the H and the T shape together. So you'll see that represented here on this next slide. You can actually use 2 H shapes and 4 T shapes together in one nest. Now, as you can see in the example with the H shape at the bottom left corner of the top nest there, a big portion of this material is not being utilized, and the entire nesting project really just has to be adjusted accordingly. But again, with our 60 different nesting algorithms, TruNest produces better results by moving the boundary of the material before even placing the first part. So sometimes the most efficient nest will be achieved by, maybe starting from the center or maybe from the right side, but rest assured our TruNest system will find the best possible outcome for the best possible results. Now, this same scenario was utilized for an actual benchmark that we did against a competitive system. Now, as you can see here, we were able to reduce the total material consumption by over 7 inches in one direction on this particular project. So it doesn't sound like a lot, but this can really add up quickly. If a shop is, cutting hundreds or thousands of the same parts, some of these flat stock materials can get really expensive. So again, please remember that not all nesting is the same. TruNest also has the ability, based on cost, to determine the best size material to use for a given order. For example, if I have 3 different sizes of one material type and have 100 parts to cut, TruNest will define the most efficient use of the material per the size. Now, that is if the cost is equal on each sheet size, but if we want to take that even a step further, we can also determine the most efficient nest based on the cost, because some situations the material has unique pricing for each sheet size available. Now, in the world of nesting, remnants are really considered a necessary evil. Most operators would prefer to do away with remnants and all the work that's involved with tracking of the remnants altogether. Now, with TruNest, we have some unique functions and features that allow users to track their raw stock and their remnants even from previous projects. So you have the ability to actually save the remaining rectangle or even stair-step shapes within TruNest in TruNest, and then have them automatically placed back into your inventory for future nest jobs. So as you can see in the examples above, the scheduled nesting job will, probably only use about 60 to 65% of this total sheet. Now, with TruNest, users can also include single part fillers, as you see in scenario 1, or even use parts from future orders to fill the sheet, like you see there in scenario 2. But in these examples, the remnants would just be eliminated altogether by running common parts or using future parts to maximize the material efficiency. So earlier in the presentation, I'd mentioned that TruNest comes standard with some special tools and optimizers that improve the overall nesting and cutting workflow. So what I want to do over the next several slides here is just dig a little deeper into some of these features that you see detailed here. Now, these optimizers really help to set TruNest apart from the other nesting systems, and does it by automatically completing just some of the initial steps that are typically involved in the process, and reducing the interaction time that's required to cut the parts. The part tabbing optimizer really just takes the guesswork out of tab placement, and does this by automatically placing the tabs in defined locations of the part skeleton. Now, this will improve performance of older machines. It increases productivity and will assure a higher quality of parts also. So a variety of tab sizes and shapes are used, and that reduces material handling and gives better control to the nesting process. And the chain or bridge cutting optimizer automatically generates the NC toolpath to find the shortest distance from part to part. This also increases productivity by minimizing cut times with really fast and efficient NC files and improved material utilization. So the need to pierce is also reduced, and the continuous NC toolpaths are prioritized. Now, the minimum piercing optimizer, or also known as the reduced piercing optimizer, that automatically locates optimal lead-in points to reduce the need to pierce the material during the cutting operation. So this saves programming time, it saves consumables, and also improves the quality of the parts. This happens because the kerf is also utilized to cut the next part to produce more efficient nests. The sheet cutting optimizer automatically cuts sheets into user-defined pieces or sizes while avoiding the other parts in the nest. So this reduces labor and also increases the value of the scrap. The common line cutting optimizer in TruNest merges the common tool paths from multiple parts in a Nest project. And this optimizer also reduces the number of pierces to improve material yield, improve machining time, and maximize productivity. Now, another optimizer that improves the manufacturing efficiencies within TruNest is our head-down logic approach. So instead of using the same fixed lead-in on duplicate parts, TruNest automatically locates lead-ins and lead-outs to create a shorter tool path while avoiding crossing over the previously cut parts. So this allows the machine to traverse with the head down, knowing that it will never crash into any tipped up parts. And TruNest also offers a standard tooling functionality that includes both a graphical representation of the tool and a representation in the tooling database. So this allows us to automatically tool parts and taking into account the features of the parts and cycles of the tool usage to minimize the tool changes within any given nesting project. So this will also reduce machining time to improve the overall efficiency. Now with punch nesting in TruNest, tool paths are optimized to, again, minimize the tool changes and to auto reposition for optimal performance. We're also able to detect for material slivers of specified sizes before cutting. So that allows us to auto destruct any type of floating scrap, and that just provides improved operator safety. The auto tooling feature for TruNest will also allow users to define parameters around their punching processes for reduced machining and part setup time. This can include distinct tools for venting hole creation, louvers, and other specialized type of formed parts. Auto tabbing is also utilized when punching for reduced material handling. Now, just to quickly summarize what we've been talking about this afternoon, TruNest is an enterprise nesting solution that has been developed for approximately 30 years now. So by improving material optimization, offering machine tool flexibility, providing direct integrations to Autodesk design tools, and seamless integration to ERP, TruNest can provide value to really any nesting operation, large or small. And finally, please remember that not all nesting is the same.
All right, Trevor, good stuff. Thank you very much. So here's a question. Any support for Combi systems?
So the answer is yes. When you say combine systems, I'm assuming something like a punch laser scenario or a punch plasma, something of that nature. So if that's the question, the answer is yes. We can do that with a single machine that has those two technologies incorporated into it, or there are customers that we support where we do it with two independent machines where there's a single laser and a single punch press or plasma. So we have that. We have the ability to sync up the different work cycles on each of those processes. So if that's the question, then yes, we support combine machines.
It says, I also saw FMS support. Does this include TK and the stack?
I'm not sure what that's referring to. If I can get a clarification on it. If it's referring to material handling equipment, load and unload, or blanking systems, we support those as well.
Next one here, can TruNest be run using iLogic? So iLogic is the automation technology inherently within Inventor, the table-driven automation.
Oh, parametric approach?
Yep.
Yeah, the answer is yes. Yes, we do take advantage and can support an iLogic approach where we're leveraging parametric information. Does not have to be a digital representation or a CAD file.
All right, thanks everyone. That concludes the session. I'm going to leave the screen up just so people can take down our contact information. But again, thank you, and we'll talk soon.